100 million years ago, a sea split North America into two land masses. But how did it form, and how do we know? Favorite this video and send it to a friend to learn more about the Western Interior Seaway. In the late Cretaceous, subduction along the west coast of the Americas had commenced, resulting in the Laramide orogeny, better known as the early growth phase of the Rocky Mountains. When the subduction occurred, the continental crust buckled, and the area east of the growing mountain chain began to downwarp. In its earliest phase, the Seaway began when an arm of the Arctic Ocean transgressed south over western North America and formed the Maori Sea. In the south, an extension of the Tethys Ocean transgressed as well, and over time the two extensions merged, forming the completed Seaway, creating an isolated environment for land animals and plants. During its largest extent, two great continental watersheds drained into the sea from both Laramidia and Appalachia, diluting the waters and bringing resources and eroded silt that formed shifting delta systems along its low-lying coasts. On the eastern shore, there was little sedimentation, but the west consisted of a thick clastic wedge that eroded eastward from the severe orogenic belt. Geologists can infer that the Seaway was warm and tropical due to widespread carbonate deposits with abundant calcareous planktonic algae. That's a mouthful. Prominent examples of these deposits include Monument Rocks in Kansas, which I will cover in depth in another video. At the end of the Cretaceous, the Laramide orogeny continued and hoisted the sandbanks and muddy lagoons, which are seen today as thick sequences of silt and sandstone in the Laramie Formation, and low-lying basins between them gradually subsided. The Seaway divided across the Dakotas and retreated to the south, and this shrunken and final phase is sometimes called the Pure Seaway. Make sure to follow as we dig more into the specific rocks.